In this video, we're going to talk about ionization energy, which is just the energy you need to put into an atom to remove one electron. You do this if your molecule is a gas, and this is endothermic, which means you have to put in energy. And electrons in the valence shell are the easiest to remove, and they will have the lowest ionization energy. So let's take a look at these two equations. We have a metal, and we have to put some energy into it to remove one electron and give it a +1 charge. Now with that +1 metal, we have to put another amount of energy, ionization energy 2, to make it a M2 plus and another electron. So IE1 is the first ionization energy, IE2 is the second ionization energy. And you can have third, fourth, fifth ionization energies. Now, the trend in ionization energy is the bigger effective and nuclear charge on an electron, the harder it is to remove it, the more energy you need. That makes sense. Electrons are negative, the nucleus is positive. So if an electron is feeling a lot of positive energy, it's not going to want to move away from that energy, so you'll have to put a lot of energy into it to remove it. Also, if your energy is very far away from the nucleus, it's not feeling the nucleus at all, so it doesn't take much energy to remove that electron. So if we look at it the first, and this is just first ionization energy. As we move down a group, it is easier to remove an electron. First ionization energy decreases because our atoms are becoming bigger, our valence electron shells are further away from the nucleus. As you go across a period, it is harder to remove an electron. The first ionization energy goes up because your valence electrons are feeling this greater effective nuclear charge, as we talked about in previous videos. So the trends in ionization energy, one, are based on two things. One, the distance between valence electrons and nucleus, and two, the effective nuclear charge. The larger the orbital, farther distance, less attraction, lower ionization energy. So as we move down a column, ionization energy becomes lower. Now as you go across a period, the effective nuclear charge increases. You have more attraction because of Coulomb's law, and so it is harder to remove that electron. So there are some exceptions to these trends. So if you go from 2A to 2-3, or 3A and 5A to 6A, the energy is a little different. So if we look at nitrogen, you're breaking up this half shell, so that takes a lot of energy. With oxygen, you are removing this electron that's already paired, so that causes less energy. So nitrogen actually has a higher ionization energy than oxygen because of the paired electron versus non-paired electron. And if we look at different trends, as you go from first to second and third, it is harder and harder to remove electrons. Ionization goes up because as you remove valence electrons, the electrons that are left are going to feel a higher effective nuclear charge. They'll move closer to the nucleus, so you need more and more energy. So if you just look at this chart, this is the different ionization energies. You can see it goes up a lot after the first electron, second electron, third electron, so on and so forth. And that's it for ionization energy. See you in the next video.